I want to touch on web technology, BMS web technology. Make sure we're all on the same page. Many of you have a BMS system that may start out with a graphic like this, but where does the information come from? Just for discussion purposes, let's talk about system architecture. Almost all organizations today have an IT infrastructure network. And there are servers on that network that give employees and occupants the information they need to do their jobs, whether it's accounting, payroll, R&D, sales. Those servers are out there. We use websites every day, Delta Airlines, Amazon.com. Those websites provide the information that we want to use. Well, web control is in fact an application that runs on a website. The number of users is not limited. So that would be installed either on your company's network or Harris Integrated Solutions provides hosting. The information comes to that server website through connections to the building where there are individual controllers tied into sensors, etc. This may be very basic, but the data flows up to the website and becomes deployed in the web screens. So when we look at a building, the information that we see is simply a web page being served up, just like any other web page. In web control, colors have meaning. For each zone, we can establish an ideal range. So ideal ranges are basically within the energy deadband. So we can glance at a building and see the conditions of the zones throughout the building. Obviously, we've got a problem here on the first floor. You'll notice we can also tie in lighting, fire, and security as well. We touched on something called the environmental index as a way of balancing and understanding the difference between, or the balance between the energy that we're using, in this case 55 kBTUs per square foot, against the conditions which are saying 98%. We've got an environmental index of 98%, which is a very high rating that we're achieving. Okay, let's go to that first floor. Here I've got the individually controllable zones and the relative colors. I go to the problem zone, the conference room. I see the actual equipment that controls that zones. Now we see this zone showed up in the color red. At the lower end, I see that the zone is currently occupied and that its green range, which is its energy deadband, is set between 62 and 66 degrees. The white vertical line, 72 degrees, is the zone temperature. That intersects the active bar in an area that's red and is why that zone shows up red. To change the set points, it's very simple. Drag and drop. When a zone is unoccupied, the bottom bar controls the set points, and we would see between the low limit and the high limit, we'd see the zone show up in gray. Pretty straightforward. Now, one of the things automated logic developed a number of years ago was a way of doing demand control. It was studied by Lawrence Berkeley National Laboratories that allows, in response to demand in a building, these set points to float and expand as a way of curtailing demand in non-critical zones. So if you've got a building with 400 zones in it, and you take all of those cooling set points and raise them by, say, ½ degree, you're going to reduce demand. Fan's going to keep going. You're still going to have airflow, but you're definitely going to reduce demand. I can go to trends. Now, if I could move that bar. If I go to trends, we talked about all points trending. Here's where I can see information about that VAV box. I've got 4 displays here, and each display can have up to 4 bits of information. So if I want to take a look on a calendar basis and I want to see an entire day, I can see, for example, the top one is CFM flow and set point. I can see when the unit became active. I can see, for example, the unoccupied set points coming down to the occupied set points by occupancy time. Very powerful. Very powerful diagnostic tool. Linking. In a large complex building, I may have a number of air handling units and hundreds of VAV boxes. The linking on the graphics allows the operator to go directly to the correct air handling unit that serves that zone. From there, I can go to the chiller plant. From there, I could go to an individual chiller. Maybe I want to look at the chiller plant energy. You notice how easy it is to navigate. You can simulate certain loads, etc. The reverse arrow takes me back where I came from. Okay. On the first floor, we talked a little about, we saw a little video about something called Timelapse. I'm going to select 8 hours. I want to go back today for 8 hours. It's going to start at 2:40 a.m. and end at 10:40 a.m. current time. I say accept that. And what we'll see, remember I said when the zones are unoccupied or under control of unoccupied set points, the zones would show up gray. You'll notice the zones, the majority of them are showing up gray. It's now 4:30, 4:50, 5:10, 5:20, 5:30, and we're beginning to see the zones come in the optimum startup routine. And here we are at 8:20, and we see all the zones active. It's a great diagnostic tool. You may ask, how do we schedule these things? The system works in a hierarchy. For example, Monday is Columbus Day. If I have schedules in all these zones and all these buildings, and I want to put in a Columbus Day schedule to put everything unoccupied for Columbus Day, I'd simply go to the highest level in the system, which may be your campus, maybe your school district, would simply go to schedules, and I would add a holiday schedule. And that holiday schedule would then affect every zone in the building. Has anybody ever had any problems with maintaining and managing alarms? The hierarchy works the same way. Right now, I'm at the particular building. If I go to the alarm page, I'm going to see a plethora of alarms. The problem is how many, how do I deal with that volume? I say I don't want to look at all categories. I just want to look at HVAC critical. And I have some. If I want to investigate a particular alarm, what we find embedded in the alarms are, again, web page links to take me back to the source of that alarm. Makes it very easy to navigate and manage alarms. Let's take a look at dashboards and the power that they can afford us. We talked about the environmental index. We can have a dashboard that shows us, again, by floor, our energy usage down here and our satisfaction level right here. If we're doing fault detection and diagnosis, we can see energy, environmental index, and the total types of fault detection and where they're coming from. Again, all of this is available in WebCTRL. We'd love to help you. Please feel free to contact Harris Integrated Solutions at harrisintegration.com or send an email to sales@harrisisi.com. Thank you very much.